we started studying chemistry with the idea of defining what chemistry is all about. We say that chemistry is a branch of science or a branch of pure and physical science that studies about matter, its composition, structure, properties, changes matter undergoes, the principle underlying the changes matter undergoes, and also the uses of matter. Here we believe that when we are looking into the composition, structure, properties, and the changes matter undergoes, we are actually looking into what we call nature of matter. So if someone is studying a particular matter and that person is more interested to know the behavior, to know the properties, this is actually making that person to be a chemist. And it is possible that there are so many occupations someone can actually engage himself after studying chemistry. So what I'm looking at, is there any possible for me to connect a laboratory apparatus that we can use in one particular separation technique and another? For instance, let me use example of filtration and paper chromatography. In filtration, we have filter paper, we have beaker. In chromatography, paper chromatography, you can also make use of filter paper and also make use of beaker. So it is possible for a teacher to ask you to mention two laboratory apparatuses that can be used in filtration and also in paper chromatography. After studying introduction to chemistry, it will introduce nature of matter, which I told you, whenever someone is looking into the composition, the structure, the properties, and the changes matter undergoes, you're actually looking at the nature of matter. And we group matter into element, compound, and mixtures. We say that elements will have one kind of atom, but when we come to compounds, there's more than one kind of atom combined together chemically. When we come over to mixtures, we notice that they are combined physically. So by the definition of element, compound, and mixture, you can actually differentiate element, compound, and mixture. And it is also possible for someone to ask you to classify some phenomenon or some actions or events into physical change or chemical change. For instance, someone can ask you dissolution of salt. Dissolution of salt is a physical change. Freezing of water to ice block is a physical change. And burning of firewood is actually a chemical change. Dissolution of metals and limestone in acid is actually a chemical change. So for us to say that this thing is a physical change, it means that the identity has not been changed, have not been altered. What do we mean by the identity? The chemical composition of that matter. When we say that it is a chemical change, we are looking at the identity of that matter has been changed. So the chemical composition of that matter has been altered. That is what we mean by this. So if you look at this, you can actually use it to classify some other processes or some other changes that undergoes. We can actually classify them either as physical or chemical changes. It is also possible for someone to ask you to give the person the criteria we can actually use to determine the purity of a substance. Whenever you are being asked to determine the purity of a substance, for solid, we always use what we call the melting point. It must be sharp melting point. If the solid is transparent, then we are going to look at the refractive index. It must be accurate. So if you look at this is how we can actually identify the purity of the substance. We can still use something like boiling point when we are dealing with liquid, and if the liquid is transparent, we can still use refractive index for it. Now if for instance we use color, if we use paper chromatography, and if it is something that has to do with color, if you use paper chromatography and you dip it inside paper chromatography, during the process of paper chromatography, if the color is not separated, if we have only sharp points without the color of the chromatography changing, then we notice that this is a pure chemical substance. Mind you, when we say pure chemical substance, it does not actually mean it is healthy. When we say impure chemical substance, which we normally call mixture, we are not actually trying to tell you that this substance is unhealthy. When we say chemically pure substance, what we mean here is that the particulate components are joined together by a chemical means. So they are joined chemically. So that is what we mean by chemically pure. I hope you get me on that. In the introduction of separation techniques, I group it solid from solid, solid from fluid, and fluid from fluid. It's possible for someone to ask you to mention two each. For instance, in solid from solid, something like sieving, hand picking, winnowing, threshing. We can even use sublimation and magnetization. That is what we can use in solid. When we come to liquid from liquid, we can use something like distillation, fractional distillation. We can even use distillation, fractional distillation. Two of them goes with the boiling point. We can use the immiscibility, where the immiscibility is something that we use separating funnel. So that is from liquid from liquid. You can mention two out from that, or even the three that I have mentioned. You put it in your head. So we can also have something like solid from fluid, where we have crystallization, fractional crystallization, recrystallization. We even have evaporation. We have decantation, filtration. So they are examples of solid from liquid. It means that sometimes the solid might dissolve inside the water, and sometimes it might not even dissolve inside the water. Another one that they might ask you to look into is how can you be able to separate sand, ammonium chloride, and iron filling. Here you are paying attention to the properties of this. Sand does not dissolve in water. Ammonium chloride dissolves in water. Iron filling does not dissolve in water. And the best thing for you to do is use magnet to separate the iron filings, then heat to sublime, which is ammonium chloride will sublime and it will remain sand. So you have separated the three. That is how to do it. They can even ask you what are the physical property you can use to separate something like ammonium chloride against sodium chloride. That is sublimation. Aluminum chloride against sodium chloride, sublimation. Aluminum chloride against sand, sublimation. So you need to get that in your head. It is very, very important. It is also possible for them to ask you, can you give us reason why water is a compound? Something like give us 3 reasons why water is a compound. Why is air a mixture? Why is air not a compound? They can ask you something that look like this. It is also possible for someone to tell you, to give them the gases that elements that are gases at room temperature. It's even possible for somebody to be specific, like non-reactive gases. It is possible for someone to say reactive gases. So you need to understand how to separate them. When we say non-reactive gases, we are looking at the noble gases. Something we have as helium, neon, argon, xenon, krypton, and radon. We can actually use that as the non-reactive. For the reactive one, we have hydrogen, fluorine, oxygen, nitrogen, and chlorine. So you can make use of that. And you know we have only 2 elements that are liquid at room temperature: bromine, which is a non-metal, and mercury, which is a metal. So having this in your head will help you a lot. It is also good for you to look into something like examples of elements like oxygen, sulfur, bromine, calcium, aluminium, gold. They are all elements. A sample of compound includes something like chalk, water. We can even look at common salt, carbohydrates, sugar, urea. They are all samples of compound. Samples of mixtures include something like blood, urine, milk, and so on, including brass, bronze, and air. They are samples of mixtures. So in the study of nature of matter, we also look into changes of state, where we have sublimation, deposition, we have melting and freezing. At the same time, we have condensation and evaporation. It is very, very important if you can look into that too, and also know how to use the flow chart to answer question on that. It is also possible for someone to ask you to use a flow chart to describe changes matter undergoes. If we are looking at that, that means that we have physical change and chemical change. So you just tell the person what the physical change is and what the chemical change is, and just give 1 or 2 examples of physical change and chemical change. That is good to go. So sublimation has to do with a solid moving to become a gas, and the opposite of this sublimation is deposition. So I want you to be able to classify, differentiate between something like extensive physical properties and intensive physical properties, something like physical changes and chemical changes. If you have the idea of all this, I believe your test will be a little bit easier for you.